Peace and love. Sorry about that, guys. The live timed out. Peace and love to everybody tuning in. Shout out to everybody joining. Welcome back. Let's get it. Let's get it. Let's get it. Are y'all ready? Because I'm ready. Are y'all ready? Because I'm ready. Right? Are you ready? Because I am ready. Let's get it, right? So, let's start off with energy. Right? We just explained distilled water is good for you. There's no added metals in there. Right? I actually tested it on a TDS machine, which is a machine that actually you put in water and it tests the metal count in water. So we've tested it like multiple times over different variations of water, and this water has the least amount of metal count. So this water, I definitely recommend that y'all be sipping this and y'all be drinking this. I switched to it and never went back. You feel me? So this helped me with my skin, everything. So let's get into it, right? So there's 4 states of energy, right? There's 4 major aspects, 4 major forces of nature, right? 4, like what we call elements, right? Water, wind, earth, fire, right? Let's go to Hebrew, right? What does God mean in Hebrew, right? Ha-he, ha-he, right? Ha-he, vahe, right? Which means God in Hebrew, which means the Father, the Mother, the Son, and the Daughter, right? 4 letters, right? There's 4 sections in the Kabbalah, right? 4 sections, which are correlated to the 4 elements, which we know, right? And now let's bring on some math, right, guys? Because I love my math, right? So let's show you how powerful, right, these 4 states of matters are, right? Let's go to basic math. What does this get? Right? What does 1 plus 2 plus 6 equal? Right? Let me know in the comments. Peace and love, goddess. Let me know in the comments what this means. Distilled water. Distilled water. Guys, let me know in the comments what this means. 10. Facts, my brother. 10. Right? Why is that important? Right? Why is that important? Why is it so important? Right? 10 is the number of creation. Remember that. 10 is the number of creation. Right? 10 is equal to creation. Why is that? Right? Creation equals life. Right? Why do I say that? Why do I say that 1 plus 2 plus 3 plus 4, right? Which we got fire, wind, right? Water, right? So we add up fire, wind, earth, and water. We get, right, our little earth, right? Which is creation, which is life, right? Which, if you understand vortex-based mathematics, right? You can't go over the number 9, right? So now, real quick rule before we get into this stuff, right? In vortex-based mathematics, right, you only have one number 9. No number can exist past the number 9 except for 10, but 10 equals creation, right? So when you get the number 10, right, you have to drop out the 0 and you simplify it down to 1, okay? Right, so if we have 15, it's past the number 9, so we have to simplify it, right? So we just add it together, right? So 1 plus 5 equals 6, right? 11, right? It equals 1 plus 1 equals 2, right? So this is how we stay within 0 through 9. Why do we stay through that, right? Here's a circle, right? Obviously, this is the shape of our planet. When we look at the sun, right, we see a circle in the sky, right? When we look at the moon, we see a circle, right? So when we're looking at these celestial deities, these celestial bodies, right, we notice certain geometry shapes. Right? So when we look at the sun, we look at the moon, right? We see circles. Let's break down a circle, right? Because also a cell is in a circle, right? So a circle has how many degrees? 360 degrees, right? Let's use our vortex-based mathematics, right? Like we just talked about, guys. Right? So what is 360 break down? 3 plus 6 plus 0 equals what? 9, right? So now we get a 9, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay? Right? Now, what is this? This is the mathematical, the fingerprint of God. This is the mathematical formula for the fingerprint of God, right? So this is the way that energy manifests itself into physical manifestation, right? Through the movement of energy, right? So we have to double everything, right? So the reason why we double everything is because everything is symmetrical, right? Everything is a double of everything, right? As when a cell replicates itself, it replicates an exact image, a double of itself, right? Then that cell replicates a double of itself, so on and so forth, right? So this is why we double these numbers, right? So let's break down a couple easy formulas, right? So 3 times 2, you get 6, right? So we got 3, right? And remember, right, like Tesla said, right, if you want to understand the universe and cosmos, understand 369, right? Understand 369. Let's understand it. Let's see what Tesla was talking about, right? It's probably breaking up because now I'm getting into some real things. Can you hear me? Yo, let me know if y'all can hear me. Let me know if I'm coming in clear, because if I'm not coming in clear, I'll end the live, we'll save it, and we'll start up a new one. Peace and love to all the beautiful goddesses, all the beautiful, handsome kings in the building. Right, shout out to y'all. You feel me? Let me know if y'all can hear me. We good? Good? Okay. When I start showing you this math, right, this is high-level information, so I'm not surprised if it starts becoming breaky or laggy and things like that, okay? So why do we double everything? We double everything because when our cells replicate, that other cell is a replication of our is a complete double of our cells, right? Have you heard of the double ganger theory? To where there's an exact copy of you somewhere in the world, right? Double. So we're doubling everything, right? So 3 doubled equals 6. 6 doubled equals 12. Right, which simplifies, which we know that it can't go past the number 9, so we got to simplify it. So 12, so 1 plus 2, right, equals 3. Right, now 12 times 2 equals what? 24, which breaks down into 6. So you see the common denominators. Right, let's go a little bit deeper real quick. So 24 times 2, which is doubled, you get 48. Into what? Do y'all know? Right? So there's a reason why I'm explaining this, right? Because this movement, right? This is how energy moves within a wave. Right? Like niggas talk about energy, but don't tell you, right? That within a wave, there's energy fluctuating back and forth. That's what's giving the characteristic or the movement of the wave, right? So, for example, right? Niggas will tell you that what we observe, right, becomes solidified, becomes materialized or particleized, right, into a solid. And when we're not observing it, right, it's waveform, it doesn't exist, right? This is quantum physics, right? So when we're not observing objects, it's in waveform, right? But what are waves doing? They're vibrating. They're moving. So that means there's energy signature, energy source that is found within the wave when we're not observing it. Let's go deeper. And this is how you know that no teacher on here is teaching you this shit, right? So let me show you how a wave, how energy transfers through a wave, right? It does it in a oscillation manner, right? So mind you, right? If I was to, let's say, right, flick that end of the motherfucking thing, of the wave, right? Here's point A, here's point B, right? Let's get rid of this real quick, right? If I was to flick this point A, right, that energy that I generated from the flick is going to transfer through this wave. And it's going to take either a second or two to transfer and hit B, right? Or 6 before, right, it bounces back or reflects back, right, and loses energy and hits back again and reflects back and hits back again. But every time it's losing energy until it becomes non-existent. Okay? So if I flick it, right, there's power behind my flick. Like, that's why your flick hurts when you flick somebody on their skin. That flick, that's energy that you're building up within your hand, right? So when I was to flick this 3 or this A, right, this energy is going to travel instantaneously. As soon as I hit it, it's going to ride on here, traveling along this wave until it hits point B. Then it's going to travel back, slowly losing the energy that it started with, then back again. And a perfect example of this, and you can try this experiment at your house. Go to Five and Below. Go to a Dollar General. Go to a Dollar Tree, and go buy you a Slinky. Right now, what I want you to do, okay, is you can hook that Slinky up to your doorknob. And you know what? Fuck it, I'm gonna go get a Slinky tonight. You know what? I might go after this building, go get me a Slinky just to show y'all this shit. Like, only like $3 at the dollar store. I got a dollar store right up here. I might go and actually show y'all this. But you know what? I'm gonna go do that later. But if I was to stretch out the Slinky, right, and put one end hooked onto a door, another person holding that end, and I was to stretch that end and walk across the room in a straight line to where the Slinky stretched out. And if I was to push the Slinky, as in still hold it in my hand, but push it, like we used to do this shit in elementary. Push it in our hand, right? You're gonna see the energy transfer up and down that Slinky in a waveform, back and forth until it's non-existent, until it loses speed, right? So this is how energy moves within waves, right? It moves this and back, this and back. Let me give you another example, right? We've all been to an amusement park, right? We've all been to a carnival, right? Have you ever hopped in those pirate ships, right? I'm gonna show you. I'm gonna draw it for y'all guys right now, right? Here's like the little stand, right? And then you got your pirate ship, right? And there's seats all here, right? And it's basically hanging like that. And basically it swings back and forth. You ever rode that carnival ride? I know you rode that carnival ride, guys. Come on. I know y'all rode that ride where you hop in that pirate ship boat and it starts off like this. Like, it starts off like this, right? Here's the boat, right? You hop in, there's people, right? It's hooked on to a mechanism right here, right? Which this is bolted to the ground, right? Lost that in this, and then they turn on the machine. It starts swaying back and forth, right? It starts swaying back and forth until that hull literally is like damn near up here. Like, I mean, till that boat's right there. And then it's whoosh, like a pendulum. Exactly, right? This is the movement that follows. Like, this is the law that it follows right here. Is the oscillation, the back and forth. Mind you, right? Let's go a little bit deeper. Let's tap into 18 or older. So if you're 18 or younger, leave the room, right? But if you're an adult that has experienced intimate relationships, the penetration of the dick inside the vagina going in and out is the same movement. And that feeling of ecstasy, that feeling of them higher vibration of orgasmic feelings is being generated by the penetration, by the movement of energy, which is creating that. Y'all don't even realize that y'all are partaking in advanced chemistry and don't even know it. I'm being for real. Like, you're laughing, but that shit is real. Like, that shit is really real. The insert of the penis and then the pulling out, that is the 3, and then doubling to 6. Then back in, which is 12, which breaks down into 3. Then back out again, which is 24, which breaks down into 6. Now back in again to hit the 3, which is what? Like we showed you here. Right? So this is the energy that this ship follows, that a wave follows, right? How energy transfers within a wave. This is energy that you follow in bed, right? So I'm showing you all this to show you, right, the power of the number 9 and the number 10, right? But trust me, I'm coming to a point here, right? It's a lot of stuff. I'm just showing you how it connects and interlaces, right, amongst all different subjects, okay? So let's finish out the formula real quick, right? So 48 times 2 give you 96, which breaks down into 15, which will give you 6, right? So basically we got 369, 369, 369, right? So now, why is this important, right? So we double it, right? We double it. Oh, no, I'm fucked up. So 1 doubled equals 2. 2 doubled equals what? 4. 4 doubled equals 8. 8 doubled equals what? 16, which breaks down to 7. 7 doubled equals 14, which breaks down to 5. 5 doubled equals 10, which breaks down into 1. Right? So you've probably seen the Freemasonry or the ruler, right? Like you have the little ruler right here and you have the big G right there. Like you've probably seen that Freemasonry symbol on cars or on Mason lodges and things like that. This is what they're talking about right here. They're showing you, right, in the invisible energy that lights up the physical reality. Because remember, 1, 2, 4, 5, 8, and 7. These are all the coding of the physical manifestation of particles. Okay? Right? These are all the number sequence that physical material follows. Right? The energy that creates them, like the physical material, is just different combinations of these different numbers. Right? So that was just a quick synopsis of what we were talking about, right? But there was a reason why I was showing you this, right? Reason why I was showing you this. Right, back to our equation, right? Back to our equation. So we know that 1 plus 2 plus 3 plus 4 equals 10. We know that that creates life. We know that that is creation, right? Fire plus wind plus earth plus water equals the earth, right? We know, right, that we have 5 fingers, right? We have 5 fingers on one hand, 5 fingers on right hand, right? So let me draw them out for you joints. Right? We have 5 fingers on one hand, we have 5 fingers on another hand, right? Right? So 10 equals creation, right? So God gave you 10 fingers so you can create life on this planet, right? They gave you thumbs so you can pick up wood, so you can open doorknobs, so you can maneuver in ways that other animals cannot. There's a reason why you have thumbs and different appendages. There's a reason why you have 10 fingers. It's so that on this physical plane, you can create your life. You can create a lifestyle by taking down wood with your bare hands and building you a home, by taking coconuts and making you coconut oil, by taking wood from an old tree and letting it dry out and then bending it and carving it of a bow, right? Being able to experience life here. God gave you 10 fingers to do that. This is the truth. Right? So why am I breaking down the number 4s? Because there's 4 states of matter, right? You got solid, liquid, gas, and you have plasma, right? So showing you that the 4 major building blocks of energy states in this universe, a physical manifestation, right, that we're aware of, is only 4 different phases that it can exist in: plasma, gas, liquid, or solid, aka crust, water, air, right? And I don't want to call that plasma, but fire, like you want to call it fire, you want, all right? So now let's break this down real quick before we get into some chemistry, right? So how does a solid become a solid? How does a solid become a solid, right? Let's take water. Let's take flowing water. How are we going to turn this flowing water into a solid? What's our next step? Do any of y'all know that? How would we, a box, facts, dot, right? So we had to put the water in a box, right? So let's say we got the water, right, in our box, right there, right? How are we going to, because it's still liquid in a box. Yes, you're exactly right. I thought you're exactly right. Right? You're exactly right. You know, but there's different forms of fire. But like, I already know that you down with his chemistry. Like, that's my brother right there, right? Guys, go follow my brother Thought. You feel me? He brings a new level of consciousness, like a funny, humoristic way of consciousness, and it's beautiful. Condensed energy. Exactly, Kai. But exactly how does that take place, right? So we know that this water has a flowing motion of electrons, right? So we know that water, right, is H2O. Do y'all know what that means? Right? And some niggas just think that it means this. That's water. No. Let me show you water, right? So you have to understand, H2O means 2 hydrogen atoms, 1 oxygen. Right? We're going to do oxygen atom. right? Now, we know how much protons and neutrons are in each one, so we would need to know the atomic structure, right? So we know that hydrogen atom, right, is 1 proton, right, and 1 electron. Right, this is the hydrogen atom, right? We know that oxygen, right, has 8 electrons, 8 protons, and 8 neutrons, right? So let's draw a big circle. Let's draw 3, 4, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? So we got protons, 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 neutrons, 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 right? That's 8 and 8. So there's 16 particles within that nucleus, right? Now, right, you have 2 electrons, right? And then you have the other 6 on the outer shell. Each layer, right, is known as an energy level, right? So electrons right here, right, are moving at a different rate than the electrons closer to the nucleus. Okay? Which means different characteristics, okay? So now, right, this is an oxygen atom. Okay? So how are we going to take this atom and this atom to form what we see in rivers? We have to do something what is known as bonding, right? We would have to bond hydrogen with oxygen with another hydrogen just to create the water molecule so that it can manifest itself into water. Okay? So what's the step that we would need to take? What's the step that we would need to take? Just real quick, right? Right? So now what we're going to get into real quick before we go back into that, we're going to get into the 3 different bonding stages, okay? There's 4 different bonding stages, but we're only going to talk about 3, right? Like we're not talking about nuclear fusion bonding. We're going to be just talking about the 3 major bondings, which is covalent bonds, right? You have metallic bonds, which are metals, and then you have ionic bonds, which are gases. So you have covalent bonds, right? You have ionic bonds, which are basically gases, and then you have metallic bonds, which are basically metals that are on the like metallic metals that are on the periodic table. Okay. Now, these different bonds do different things. Okay. So when you have an ionic bond, right? So let's break down a covalent bond, right? So a covalent bond is when 2 atoms, right, share their electrons in order to create, right, a new atom, right? So a covalent bond is 2 atoms that share the same electron in order to create balance or a new atom, right? Now within covalent bonds, there's different types of bonding, right? You have single bonds, you have chemical bonds, you have double bonds, you have triple bonds, right? We're going to be keeping it real easy for today. So we're going to be going over single bonds and chemical bonds, right? And then tomorrow or the next day, or like tomorrow, we'll go even deeper into the next step, right? It's a day-by-day process, okay? It don't take one day to grow a motherfucking tree. You know what I mean? Especially an apple tree, it takes about 2 to 3 years. You feel me? So if you planted an apple seed, and I saw you plant an apple seed tomorrow, and I come back 2 days later, and it's a full-grown apple tree, I know that something's not right. You know, I know that food's GMO. You know what I mean? So we're not going to learn all this information in a day is basically what I'm saying. So a single bond, right? Remember, covalent bonds is with 2 atoms. So a oxygen atom and a hydrogen atom are 2 different atoms. Share their electron in order to create a new bond, right? So that means, right, which water is part of the covalent bonding, right? So that means hydrogen and oxygen have to share an electron to become bonded into what we know as water, or what we experience as water, right? So look at your water, right? If you have a clear cup, look at your water. Watch it as it move around. Now, what I want you to do is, this is a filter that we have, a sense that we have. It's a gift of our gland. I want you to look into the water. And I want you to visualize in your mind's eyes small particles floating around in that water. Okay? When you visualize that, what you don't realize is that you're tapping into the microscopic world. Right? It's called remote viewing. Our pineal glands have the power of microscopes and telescopes, right? So we have the ability to travel anywhere across this world with our consciousness. When in a matter of an instant, our body can be here and our consciousness can be all across the world. This is known as superposition, right? So when you activate your pineal gland and you look at the water and you really focus and you start to visualize and start to particleize in your mind, you start seeing the different atoms in your mind. You don't realize is that you're activating your microscopic gland in your pineal gland and you're viewing in that dimension right now. Right? So that's just not your imagination. You're tapping in to the microscopic dimension. Okay? I'm trying to let y'all know something here, right? This is how your consciousness remote views and ascending facts. Now, right? So let's come back to the board. Right? So let's look at a chemical bond, right? A chemical bond, okay? Right? Is an attraction between two atoms, right? That are forced, and a force that holds them together, right? So a chemical bond is an attraction between two atoms and a force that holds them together. Right? This attraction, right, is from the positive and negative charged particles called electrostatic force. And I'm going to get into that deeply in a second, right? But let's go back to hydrogen. Let's go back to water, right? So we were talking about the different stages of energy, right? So how can we turn water into a solid, right? As the goddess said right here, right? Is condensed energy. You're exactly right. But let's analyze that. Let's zoom in closer, right? What is energy? The atoms, right? Now, condensed atoms, right? First, we have to understand atoms before we understand how they condense, okay? So we got an oxygen atom, we got a hydrogen atom, right? So we know that through single bonding, right? And chemical bonding, right? That electrons attract themselves, right? So now, right? This oxygen atom is now pulling or beaking in or magnetizing two hydrogen atoms to form this water molecule, right? So now, right? This hydrogen molecule will now come over here, right? And now it will begin sharing. Hold on, I fucked up. Right? Here's the proton of the hydrogen atom. Here's the electron. Righty? So now we have HO. We have HO, right? We have hydrogen, oxygen binding together, right? Due to covalent bonding and due to the electrostatic force, which that's the attraction between two electrons, or a positively charged and a negatively charged electron. Okay? So now what's taking place is a chemical bond, right? So now to form what we know as water, H2O, this atom now needs another hydrogen atom. So on this side, it'll start beaking out, right? And it'll start attracting another electron, right? So now, right, the hydrogen atom now floats into its direction like a web and now gets locked in, right? So you got the proton and neutron. So you got hydrogen, you got oxygen, you got hydrogen, right? Now, this is the molecule, this is the atomic structure of water, right? So the water that you have in your glass, the water that you have right here, right? This is the actual structure, the atomic layout, microscopically, of water, right? And mind you, right, all these electrons are all orbiting each other, right? So these electrons are all moving in a certain direction. So let's say they're all rotating clockwise, right? Depending on what hemisphere they're on, they'll rotate is directly to the hemisphere, right? So I showed y'all how in the northern hemisphere, everything rotates counterclockwise when it comes to energy and water. Flush your toilet if you live in America, and you'll see how that hoe rotates counterclockwise, right? Flush your toilet if you live in like Latin America or the South, right? It'll rotate clockwise, okay? So these atoms are going to follow the direction on which hemisphere they're on, right? So let's say that this is in the southern hemisphere, this atom. So the electrons are going to rotate clockwise, right? So this electron that's connected right here that they're sharing due to electrostatic is going to rotate, right? Constantly. This proton is spinning as well in the opposite direction. All these protons are all spinning and orbiting, and these neutrons are all spinning and orbiting each other. You remember, all these electrons are a constant fluctuation of moving parts. It's almost like, right, if we had 3 suns, 3 solar systems, and all these different planets all interline with each other, and they're all orbiting the 3 different suns at 3 different rates. That's how it would look. So imagine all these 10 electrons all orbiting at different rates, and the protons spinning and the neutrons spinning, right? And this is what's generating the flow of water, which this will attach itself to another version of itself, then another version of itself, then another water molecule, then another water molecule, then another water molecule, until it forms what we know as water. Right? Now, right? Facts, thought. Exactly, my brother. That's facts, right? So we know that in water, right, it's more flowy, it's more loosely. So we know that the atoms, right, this atom is just, they're not as tight and like girls, and like the goddess said, right, condensed, right? So how do we make the atoms within the flowing water, right, become condensed? How do we do that? How will we condense these atoms? How will we stop them from vibrating all flowy to make the form of water? I paused. Hello, am I good? Hello? Am I good? Let me know if I'm good. I'm good? Okay, bet. I'm not sure if it's your live goddess or what, but let's get it. Right? So how do we slow the movement of this water molecule? Because the movement of the water molecule is what's creating the form of water. That flowing pattern, these water molecules are moving in that flowing pattern. So how do we slow down the speed of these water molecules? What environment do we need to put them in, right? What environment slows you down, right? Come on, guys, use y'all's experience, right? I have y'all tapped into chemistry, but now let's go back to your normal life. How does water become a solid? Right? Use your experience. How does water become a solid? Y'all know this. Boom. She got it. Temperature. We've all had them old ice cubes to where you motherfucking pour the motherfucking water, from the motherfucking sink into the little ice cube tray, and you let it sit in the motherfucking sink or like let it sit for 4 hours, and them hoes got perfect ice cubes. Right? I used to put Kool-Aid in them bitches. You feel me? And used to make motherfucking Kool-Aid ice cubes and pour them hoes inside my Kool-Aid that I already had. That's how that's how much I had a sweet tooth, and I love Kool-Aid. I used to put Kool-Aid with massive amounts of sugar into the ice cubes and make Kool-Aid ice cubes, and then pour them hoes into my Sprite or like pour them hoes into my ice, like my Kool-Aid to make them even better. I would have like red, green, blue, orange, fucking all the motherfucking shits. You feel me? Scroll more in-depth breakdown of temp. Did my brother thought break down temperature real quick? Cause I can pull up the definition, right? Unless my brother already explained it. You might have to scroll up in the comments to see. So, okay, yeah. So the temperature is what slows down or speeds up these atoms, right? So y'all's freezer, right? Literally, the coldness through epigenetics affects the movement of these electrons. The same way how the cold environment slows you down, right, is in normal weather, in room temperature weather, right, you can move your fingers fast as fuck, right? But when you're in the cold and you don't have any gloves on, your fingers become ice cubes, you can barely move them, right? So you don't realize that the temperature slows down the degrees of movement, like my brother Thought said, right? Which slows down the speed and the movement of the electrons and the speed and the rotation of the neutrons and the protons, which slows down the water molecules together, and it becomes solidified into an ice cube, right? So now you have all these molecules that are moving around everywhere, right? Now they're now slowing down and they're consolidating. They're coming together. They're solidifying. Yo, that's lit. That's lit. You know? So water, when it's solidified, turns into ice. Right? So water, right, in solid form is known as ice. What force slows it down? Cold temperatures. Right? Cold temperatures, which I'm going to break down temperature in another build, like later on. Right? But cold temperatures slow it down. Right? I'll break down the force in another build. Right now we got water, right? Which is in liquid form, which is in its natural state. What is water when it's heated up, right? Because how do you get gas, right? You heat up water, right? We've all boiled water for our children when they play football, for mouthpieces, when we're making spaghetti, when we're making all different types of meals. We've all boiled water before, you know what I mean? For soup, right? So that steam that y'all see is coming from the boiling water. Like, y'all don't realize that that's the water molecule, right? Rearranging itself into a higher vibrating version of itself, a more refined version of itself, and it turns into steam. So the gas version of water is steam, right? And if we were to catch that steam, right, and be able to actually heat that steam up, we will get known as plasma, right? Which that's another build, because I'm gonna build on plasma. I'm gonna have a whole lecture, whole build on the fourth stage of energy, the hidden stage of energy, right? So I'm gonna save that for another build because things, right? So those are the four stages of energy, right? So we have to know that before we dive into chemistry. We have to understand that when we take magma, right, and we cool it down, it forms the rocks that you see at Hawaii that I just showed y'all, right? So let's pick up the iPad real quick. Right, like, remember how I was going over, right, Hawaii and how it has active volcanoes, right? So when magma cools, it forms this. Right, forms that. Now let me show you an actual video of lava actually touching water and cooling off right before your eyes, so that you can have the experience. Because it's all about mental images. You know, it's not about the words. It's about the mental images, right? And how you perceive it mentally through shapes rather than words, right? So let's look at lava cooling into rock. So let me show you how when lava cools off, right, and the colder temperatures hit it, it cools down into a more solidified state, right? So look. So you see how the temperature right there is keeping it liquid, but as it hits the surface, it solidifies, right? So that's lava, magma turning into rock by temperature, by cooling, by heating, etc., right? And what happens when you heat up magma into a gas form? Like, what does it create, right? Like, remember what I told you. This magma, the composition of magma is nickel and iron. So when this nickel and iron gets even hotter, it can heat up, right? Ill is intelligent. Yo, he is intelligent. Like, my brother is intelligent. You know what I mean? Like, it's that dude really go deep with his shits, right? And this is how he talks. But if we were to heat up that liquid magma, right, what's hot enough to even heat up magma? Right, the Earth's inner core, the iron core, is so cold that it literally heats up magma into a gas, which that gas is what we know as the magnetic field of the Earth. Y'all, like, you don't even realize that. Y'all, like, you don't even realize that this magma, when it gets converted into gas and plasma, it generates the magnetic field of the Earth. And the plasma is the aura field that we see around the Earth. right? That's another gem that I'm gonna break down another day, right? But I'm just showing y'all the different states, right? So y'all can comprehend it in many different ways, right? So you gotta understand that on this earth, there's all different forms and all different states all at one moment, right? I can be standing on a solidified version of a rock, looking at a liquid, looking at ocean, right? Moving. Also breathing in gas, which is air, right? So this planet has all the different forms and all of its different states, all simultaneously experiencing itself, right? In all different forms, right? So let's go deeper, right? So now that we know the three different types of bondings, you got metallic, you got ionic, you got covalent. We broke down as single bonds, right, which is the sharing of electrons, which forms a new atom, right? We talked about chemical bonding, right, which is the attraction between two electrons, right, through electrostatic force, right, which we're gonna get into, right? So let's get into it, right? I'm going to leave that up there. We're going to get rid of this. All right. Oh yeah, facts. I definitely recommend you go doing some research. And I mean, that's all life is just advanced chemistry, right? Here's another way that you can understand that you're the cosmos, right? That you're made from the same elements of the cosmos. The four most abundant elements in the universe is first hydrogen, helium, carbon, and oxygen. Those are the three most abundant or four most abundant elements in the entire universe. So if we ran out of hydrogen, all we'd have to do is just travel out in space, go grab a hydrogen cloud of electron and bring it back in for more hydrogen, right? Those elements will never run out of because those are the most abundant elements in the universe, right? What are the three most abundant elements here on Earth, right? And this is where we get into Hebrew, right? Now we're getting into Duhkulu, right? Which is Hebrew, which is the 22 which is the 22 letters, right? You got the 3 mother letters, you got the 12 single and the 7 double, right? The 3 mother levels is identical to the 3 major elements here on Earth: hydrogen, carbon, and oxygen. Those are the 3 mother letters, the 3 major elements that forms life here on Earth. 4 major chemicals, right? I can go into Hebrew in the different words. I can go into the 12 single letters, which are correlated to the 12 zodiacs. I can go into the 7 double, which are correlated to the 6 directional points plus the origin point. You know, I can go into the 3 mother letters, which is basically a formula for the 3 most abundant elements here on Earth. And these are identical from the cosmos. Yo, brother, I'm telling you guys, like, my brother Thought and I, we on, and Jester, like, we on a different frequency than like, a lot of these people on. So like I'm trying to tell y'all some shit. You feel me? Right? I'm showing you how this is all correlated, right? Through all different sciences, right? So we got our beautiful oxygen atom, right? We know that, right? That oxygen atom is the building block of a water molecule, right? Because without it, it wouldn't attract these two hydrogen atoms. And you have to remember, right, that this oxygen atom is made out of 8 hydrogen atoms already, right? Because we know that one hydrogen atom has 1 proton and 1 electron, right? We know that an oxygen atom has 8 protons, 8 neutrons, and 8 electrons, right? So we know that means it's 8 hydrogen atoms put together to get the 8 protons and then 8 neutrons, or the 8 electrons, right? Which, when it turns into an active state, it has to produce, so hydrogen in an active state produces what we know as deuterium, right? Which is the second phase of nuclear fusion, which we know is proton, neutron, and electron, right? All orbiting each other. We know that this is the second stage, or the active stage of hydrogen, which is just E, right? Which is just, right? You got hydrogen, iridium, and you got tritium, right? And everything is like that. We're not gonna go into that yet, right? But I'm just showing you the different things, right? So the building block of the water molecule is the oxygen atom, which has 8, right? 8 protons, right? 8 neutrons, 8 electrons, right? That is the basis for the water molecule, right? So we know that through covalent bonding and through chemical bonding, right? We know that and now let's get into some rules of chemistry, right? Because now I'm taking it deep, You know, I'm not just one of these niggas that just talk about this shit. You feel me? I actually break down the math and go through the formulas and actually show you how this shit actually bonds together, right? So we know that there's 3 different types of bonding. We know that there's ionic, which is the bonding between gases. There's metallic, which is the bonding between metals, right? Then we got covalent, which is the bonding between everything else, okay? And in between these different stages, there's substages, right? So now in bonding, double bonding, triple bonding, and hydrogen bonding, and that's a whole, those are filled, like 4 different stages of bonding, right? But we're just talking about single bonding and chemical bond through the electrostatic force, right? Which is the attraction of the electrons, right? So this is a single bond, right? This is known as a single bond, right? Now, if this oxygen atom was to attract another hydrogen atom, which would mean it'd be H3O, right? That would be known as a double bond. So on and etc. Okay? Now, right, we know that oxygen is just 8 electrons, 8 protons, 8 neutrons, right? So we know that it wants to attract hydrogen. It wants to become water, right? So it's like basically sending a beacon signal out to the other electron of the hydrogen atom to pull it into it so it can share itself, right? We know that a covalent bond is the sharing of electron to form a new bond, right? So we know that they are sharing the electron of the hydrogen atom, right? And this hydrogen atom this electron is rotating in and out of the orbital pass of the other electron, and this is what generates the movement of water, right? So I just wanted to break that down before we start going in deeper, right? Into this information. So let me know, like, are we all good? Like, are we all out of space to where we're all caught up? Right? Are we at a space right now to where we're all caught up? Right? Real quick, right? Like a real quick thing, right? So we got, where's my periodic table? Right? Let's pull up the periodic table. We can't be talking chemistry without the table. Right? Give me 1 second, guys. I'm gonna pull it up. Let's get it. Let's get it. Oh shit. Hopefully my queen didn't message me. Let me see. Okay, so I gotta finish my build in about 20 minutes because she needs to be picked up from class. So that's what I'm about to go do in about 20 minutes. We got 20 minutes to finish the build and we'll be back later. Right? So let me show you this periodic table. I make sure I don't want to make her late and make her sit up there waiting by herself. Right? So we're going in deep. It's gonna be like tomorrow I'm off too. You feel me? So I'm about to be going all day tomorrow. Okay, let me see. It's not in my pictures. Okay, so I guess I gotta download a periodic table real quick. So give me 1 second. There's a specific periodic table that I want. Periodic table. Right. So let's find the periodic table that I like. Right. If you have an iPad or a tablet, let's type this in so we can come to it. Right. So the best one that I've seen so far, periodic table, is this one right here. This gives you save image. So here's our periodic table, right? So this shows you all the different types of metals, the alkaline metals, right? The alkaline metals. I'm gonna get into all this, the noble gases, the poor metals, right? And all the different shits, right? So this is the periodic table that I recommend that y'all get, that y'all download, okay? So we got hydrogen, right? Which we know is the first element, which we know as H. So we know that is 1 proton and 1 electron, right? We know that helium, right, is 2. Which means 2 protons, 2 electrons, right? So we got helium, which is He, right? Which is He, which is 2 protons, right? And 2 electrons, right? So now, right, a quick understanding real quick, right, is that how do we get from hydrogen to helium, right? Well, you don't realize that inside the core of the sun, hydrogen is being converted into helium, and this is how nuclear fusion takes place. The same process that a thermal hydrogen bomb, takes as well, right? So all they're doing is adding 1 hydrogen atom to this right here to create helium, right? Now, once we have helium, all we got to do is add another hydrogen atom to create lithium, right? 3 protons, three electrons, right? 3 neutrons. Now you have, right, is beryllium, right? Which is 4 hydrogen atoms put together. So on and so forth, right? Hey, that's funny. Yo, y'all funny, right? But why the reason I'm talking about this, right? So let's get back into it, right? So let's get back into it, guys. So we talked about covalent bonds, right? I want to talk about the octal, right? So the octal is a basic rule that chemists usually apply, right? That tends to follow most atoms, right? So basically every atom wants to be balanced. Every atom, bro, wants to be balanced and be at an equilibrium, right? So you have some atoms that may have 3 electrons, right? They want to be balanced, so they'll try to attract another atom that has 1 electron. So they'll add another hydrogen atom, right? To basically form into the next element to become balanced, right? So they're constantly changing into new elements to reach that equilibrium state. And this is known as the octal rule, right? OCET, right? Rule. And y'all can go look this up, right? So now what I want to tap into is ionic bonding, right? Ionic bonding is a type of chemical bonding that involves an electron, right? Which is an electrostatic connection between 2 oppositely charged ions, right? And this is primarily within ionic compounds. So I'm gonna say it again, right? So an ionic bond, right, is a type of chemical bonding, right, that basically performs the electrostatic formula to attract between 2 opposite charged ions. So you have a positive ion and a negative ion, right? Through electrostatic, right, things, is to bond together to form an ionic bond, right? A form of ionic bonding, right? Chloride, like that's a form of ionic bonding because it might have 7 electrons. Or let's look at, for example, here we go, right? 5. What's 5? 5 is boron, right? So boron, right? 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 So this is boron, right? It's uneven, right? So it wants to be in a balanced state. So what it would do, it would absorb another hydrogen atom, which is just electron, right? And what will happen, right? Right? So now we got H. Oh yeah, and then you got boron dimming magnets. You got, and this is like boron is used to make magnets too, as well, right? HB, you got HB, right? Which you can have H2B, right? Which is a functional group of a different bond, right? So on and so forth, right? So I'm just showing you the different types of bonding, right? So, this follows the same principles that water follows, right? But the thing about water is a non-polar molecule versus a non-polar molecule, which we're gonna get into that in a second, right? But I'm just showing you how it works, right? So, this is boron, which has 5 electrons, right? Let's go to F, which is fluoride, right? Fluoride would be an example of a ionic bond, right? So, fluoride has what? 9 electrons, right? Which means 9 protons, right? Let's do 2 layers, 2, 3, 2, 4, 5, 6, right? So that is fluoride, right? Now, this has exactly 7, exactly. See, you understood what I did here, right? Exactly, right? Now, right? So here it is right there, right? That is fluoride, right? That's F, fluoride, right? Which means 9 protons, 9 electrons, right? So it wants to be in a balanced state. So what it would do, it'll absorb another hydrogen atom to become nitrogen, right? Which we know that what nitrogen is used for and all the different types of things that it's used for, okay? So why is this important, right? Because the thing about ionic bonding, right, is that it doesn't share the molecule with the actual like it doesn't share the electron with the element that, or with the actual, like chemical that's, looking for that extra electron, right? It actually just donates it and gives it and just becomes a proton or a nucleus, right? So, like I explained with the fluoride, right? It doesn't take on another hydrogen atom, right? The hydrogen atom gives up its electron and now turns it into 9 protons, 10 electrons, right? So it's all about the electrons, which we'll get into that as well, right? So, ionic bond basically donates, the electron to the other atom participating in a bond, while in covalent bonds, right, they're shared, okay? So, let's talk about what I want to get into, right? Okay, so I want to get into different types of ionic bonding. I want to go over, right, that in ionic bonding, right, the metal elements, right, because you have different types of elements. You have gases. So ionic, like basically works for gases, but you can also have ionic metal bondings as well, right? Without getting or tapping into metallic bonding, right? So when metals are bonded in an ionic form, right, they lose an electron, right, to become positively charged cation, right? Whereas non-metals, right, accept those electrons and become negatively charged ions. I got websites and things like that. I can send them to you, and things like that. They're just all over the place. You're gonna have to just tap into many different physics centers. But I'll definitely send it to you and things like that as well. So you can definitely go research it. It is hard level stuff to read, right? But since I'm already like familiarized with this type of stuff, I'm already, like, it just translates easy to me. You know what I mean? And then I can translate it back, right? So a non-metal, right, when it performs this ionic bond and gives up its electron, it now becomes an anti-ion or anion, right? Then you have cations, which I'm gonna get into later on. Okay. The ionic bond is also known as a electrovalent bond, right, which is a type of lineage formed from electrostatic, like attraction, right? So from electrostatic attraction, which is the attraction between electrons, right, they can perform different types of bonding as well, right? So let's get into what a polar molecule is, right? Because that's what water is, and some of these elements are actually polar molecules and non-polar molecules, which these have different functions as well, right? So we know that water is created by a covalent bond, which is known as single bonding, right, through the electrostatic force, right, the sharing of electrons instead of the donating of electron, which would mean it's ionic bonding, right? So when a hydrogen atom gives up its electron and then the hydrogen leaves or the proton leaves to go somewhere else, right, and becomes an ion, right, that is ionic bonding, right? Now, if it was to stay with the electron and allow the electron to both experience the rotation of the oxygen atom and the hydrogen atom, that's covalent bonding. That's sharing. Okay. So polar molecule is basically a form of a chemical reaction that basically is a distribution of elements between covalent bonds, right? Which are not even. So basically like what I talked about, elements being uneven and things like that, right? So, so like one thing that we have to understand is, right, that polarity takes place, right? And it is a description of, so basically I'm going to the definition right now of its polarity, and I want to show you this on Google so that I'm not mispronouncing it. Right, so real quick. Polarity definition. Polarity definition. Chemistry. So about the English language, I noticed is that they have same words for different meaning, or same words with different meanings for different subjects. I just forgot the fuck what I was looking at. Hold on, like what the fuck did I just type in? Yo, like my mind just went blank. Yo, do y'all remember what I was just looking up? Guys, we got 30 seconds left, so join me back for the next build. Peace and love. Everybody joining. Question, do y'all remember what I was just typing? Oh yeah, polarity. Polarity definition. Chemistry. Peace and love to everybody joining. Let's tap back in. Right. In chemistry, polarity is the separation of electric charge leading to a molecule or its chemical group having an electrodipole movement, right? So a dipole movement is this right here, right? So you got, right? So you'll have one be right here, and the movement in which these swing will determine the movement of the charge. So like you're seeing right there, right? So these things are constantly moving in different directions, and that is the electric dipole moment, right? With a negative charged end and a positively charged end, right? So you got a negative and a positive, right? Polar molecules may contain polar bonds due to the difference in electronegativity between bonded atoms, right? So I'm gonna get into that, right? Right? Right. So we know, right, that if the electrical poles are different, we know that it's a polar molecule, right? So if the poles of this molecule are the same charge, right? Then are different, right? Then it's a highly polar molecule. In reverse, it's a lower like polar molecule, right? So we have to understand that every atom has a specific level of electron negativity, right? And I'm gonna go into that. I'm gonna go into the definition on what electron negativity means, right? So basically, right, right. So let's go on into electron negativity. And this is how you know that these niggas don't really know anything about chemistry or atoms, because they're not teaching you any of this stuff. Electron negativity. Is a symbol and a chemical property that describes the tendency of an atom to attract a shared pair of electrons towards itself, right? So every atom has this ability. Every atom has this electron negativity, which means it's the ability to measure the amount of attraction, the electrostatic force that is shared between two electrons as they head towards themselves, right? So this is measuring the speed of the attraction that each atom has. An atom's electronegativity is affected by both the atomic number and the distance at which the valence electrons reside within the charged nucleus, right? So that is heavy. That is heavy, right? Which is basically the tendency of attraction between things, right? So an example of electronegativity elements, right, is carbon, cesium, right, francium, right? You also got boron, you got bromine, you got silicon, you got neon, and you got other elements like that. But these are classifications of electron negative elements that are highly conductive when it comes to sharing between electrons and things like that, right? So we got to also understand, right, when we're talking about the oxygen atom, right, which is basically the building block of the water molecule, we know that, it shares electrons with both hydrogen molecules, right, which is a form of covalent bonding, right? We know that the electrons tend to stay close to the oxygen atom and the outer share of the hydrogen atom, right? So it stays closer to the oxygen atom, but it's in the outer layer of the hydrogen atom, right, in the outer energy level, okay? And we know that this tends to basically perform a positively charged molecule, right? We know the oxygen atom has 8 electrons, right? And must stay away from hydrogen atoms, right? Because the outside energy level of the oxygen atom, right, is to have a negative charge, right? Which basically repels it and pulls it away, right? So you have 2 atoms that are basically negative that are repulsing away, but through electrostatic, right, they attract. When 2 water molecules get close together, right, the polar forces work to draw the molecules together. So we have, right, like a water molecule here and a water molecule here, right? The attraction between the two will pull them together, right, to form would be basically another version of itself. Like would be a doubled version of this, right? Then another doubled version until it manifests out as physical water. Okay? Now, right? So let's talk about characteristics of water. You know what I mean? And this is something that I hold very powerful to me, right? So we know that some characteristics of bonds and hydrogen bonds of water, right, is that water has the ability to dissolve anything, right? The water has the ability to dissolve anything. Salt, you can put fucking garlic in it, you can put garlic powder, you can put any type of thing, and it erodes it and it dissolves it over a short period of time or a long period of time. Okay? That's the one amazing characteristic of water, right? Also, water has low density when it's frozen, right? So that means, right, it has low density. So when water is inside of water, when ice is inside of water, right, you would think that ice is heavier than water, right? When it's frozen. But how come ice floats? Because it's less dense than what water is in its natural form. This is why when you add salt to your water, you're making the water more dense, and you can drop an egg inside that glass and watch that egg float as if it's boundless, it's weightless due to the density of the water. Okay? And that's a whole nother lecture that I'm going to do, and a whole nother build I'm going to do for y'all guys, is showing you the different densities of different mediums when it comes to air, water, magma, things like that. Right? Exactly, my brother, right? So anytime that we see about 20% of the water molecules in liquid water, right, and are freed of their hydrogen bonds, they're able to hydrate other materials in water. So basically, this is showing you how water breakdowns or dissolves every other element, right? Is that the water molecule frees itself from the hydrogen bonds and starts breaking down or hydrating the other materials within the water itself. You know what I mean? So that's a perfect stopping place that I'm going to get to right now before I have to go pick up my queen and we come back and we really tap in, right? So I hope that y'all learned a lot today. I learned a lot today, just by being on here and breaking it down and collecting everything. You know, we're going to be back on later, but I hope that, you know, this information helps you in some shape or form, whether it be positive or negative. And I hope that, that this makes y'all interested or in it, or intrigued in studying this type of stuff. And I hope that I can bring a fun, loving type of way to this type of stuff so we can understand it more simply, so that we can teach our children and we can, move on from this bullshit that we're experiencing, so peace and love. You have a great day. Induce.